Hey everyone, shout out to Sabrina for making my intro, so thank you. All right, so today I'm just gonna really quickly go over the catalyst question from last week, the one about cougars and cottonwood trees. So I wanna go over each day. I tried to make comments on like some common things for those of you who submitted, but I wanna go over everything as a whole in case you didn't do these catalyst questions. So the catalyst was based off of this experiment where the title of the graph was Cougars and Trees in a Trophic Cascade. So what I wanted you to do is be able to look at the graph, look at the data, and come to some conclusions. So what was the experiment about, and what could the scientists conclude based off the data? All right, so the first day, I just wanted you to figure out the variables. So dependent variable and independent variable. So if you look at this graph right here, you've got A and then you've got B. So cougars common and then cougars rare. So in this case right here, what they meant by common and rare is not a species type, but it was just, are there cougars in this area? There are, and then in this area there aren't. So the number one was, what is the dependent variable? And that would be, what is the scientist measuring? Okay, so what are they taking data on? And they were taking data on the cottonwood trees per kilometer. So they were measuring how many trees were in each of these areas. All right, most of you got that one right. Now number two, which was what is the independent variable? This one was, I would say 50% of you got this one right. So independent variable is always going to be what affects the dependent variable. So what is going to cause a difference in the amount of trees? In this case right here, the independent variable is going to be whether cougars are common or cougars are rare. All right, so this is what's going to change the cottonwood trees. All right, so one thing that some of you wrote is instead of cougars common or cougars rare, some of you wrote the location. So they do tell you that A is one location and B is another location. So that's fine. That is technically could be correct, but more accurate would be that in the locations, the difference in the locations is that one has cougars and one doesn't. Okay, so the other common answer that I got was a lot of you wrote the year or the time, and that's because you remember when we talked about this, a lot of times the x-axis is your independent variable, but in this case that doesn't really apply. So the x-axis, sometimes it will be the independent variable, but not always. In this case right here, you always have to think back to what's going to affect the dependent variable. Okay, so in this case, the years down here, which actually more accurately is the tree origination decade, that is just one way the scientist was organizing the data, another aspect of the data, but this is not going to affect the amount of cottonwood trees. It was really the cougars. And then number three is, according to the graph, what disruption to the ecosystem occurred in the North Fork of the Virgin River in Zion Canyon. So this is asking about graph B. What disruption happened? And that was that cougars became scarce and deer became more abundant. That's all you really had to say. This was what changed the ecosystem. This is what disrupted the balance. All right, you didn't have to explain yet. That came in the next couple days. All right, so this was the first day. The second day, number one, describe the trends and or patterns that you see in the data. So we've been doing this all year. I ask you, what does the graph look like? What conclusions can you make? So the general thing I saw from most of you is, a lot of you said when there are cougars, there's more trees. When there's less cougars, there's less trees. Okay, that could have been, that's fine. All right, so that's a trend that you see, or that's just a claim you can make based off of this graph. Some of you went a little bit more detailed and you wrote stuff like, oh, the trees, the growth in trees increase, or the growth in the trees increase and then decrease. So I saw some of you wrote stuff like that. But really the years right here are not, it's not as accurate to say, oh, the number of trees increased and then decreased. These years on the bottom are not talking about over time. It's when the tree was born. So when you look at this, it says the tree origination decade. That's really telling you that these, for example, these trees, they all were born or planted in, you know, in the 50s. So these years on the bottom, they tell you how old or how young the tree is, not necessarily that the number of trees increased over time. So for that, like really the big thing was when there was cougars, there was more trees. And when there was no cougars, there was less trees. Some of you also try to explain it with like exponential growth. So this curve looks like an exponential growth curve. That's good, but you didn't really like have to include that. And this isn't actually exponential growth. The curve looks like exponential growth, but the data actually is not showing exponential growth. For number 2 is the relationship between cougars and cottonwood trees. So I just told you that. So that the relationship is when there are cougars, there are more trees. All right. So the number of trees is dependent on the presence of cougars, and not the other way around. So some of you made a mistake of saying like, oh, when there are more trees, that leads to more cougars. But really, it's when there are more cougars, there are more trees. So sorry if that's a little bit confusing. You can pause and like look at this graph a little bit if you need to. That means that when there are cougars, so if you look at graph A, when there are cougars, you would put like more trees or an increased number of trees. Okay, and I already talked about this term right here, tree origination decade, referred to when the tree was, quote, born, not the time period of like when they're collecting data. All right, and the last day asks you to come up with the experimental question just based off of the graph. So what do you think the scientists were trying to figure out? And you could have just said something like, they were trying to figure out how the loss of cougars will affect cottonwood trees. I actually took this phrase from the background information. So I put a link to the background info, and I took that from there. You didn't have to write that. You could have just said how cougars affect the number of trees. That would have been fine. But the last question was to actually apply biology concepts now. So up until this point, you didn't really have to explain any of the biology, the why. All I really was having to do was like what you could tell from the graph. But the last one asked you to use topics from Monday's video. So Monday's video was the AP Bio, the College Board review video, which is on ecosystems and disruptions. So now what I wanted you to do is explain like why this happened. Why is it that when there's no cougars, there's less trees, using the ecological concepts? All right, so some of the vocabulary that you should have used is this term top predator. I actually took this vocab from the background information. So they listed that, they talked about that how cougars are the top predator. Trophic cascade, I took this from the title of the graph. And then keystone species is the term from the video. So in the video, they talk about how a keystone species is a species in an ecosystem that has a big impact on the ecosystem. So when you remove it, it really disrupts the ecosystem. It messes up the stability. In this case, the cougar is an example of a keystone species. When the cougars are gone, when they become scarce, the deer become more abundant because there's nothing eating the deer now. So the cougars are predators to the deer. So if there's no predator, these deer can, you know, like roam freely, and they're not getting eaten. Now, because there's more deer, the deer eat up all the vegetation. So all the trees get eaten up. So instead of having this balance of trees and the herbivore, which is the deer, the herbivores, the deers are way too many now, and they eat up all the trees. So eventually I could actually have you predict in the future, if all these trees are gone, so all these younger trees, they never get a chance to grow up. All right, so remember the tree origination decade, they're telling you the age of the trees. All of these young trees, once the deer become abundant, they eat up all these baby trees. These trees don't even get a chance to really grow up and mature because they get eaten up. So I could have you, an extension would be, all right, predict what would happen to this ecosystem if this continues. So a prediction could be, all right, well, the deer the population might decrease because of the lack of food. So once all these trees are gone, then the deer won't have any more food. Therefore, their population might decrease again, and then the cottonwood trees might increase again. Okay, so that would be a common thing on the AP test, is to predict what would happen in the future, or predict, yeah, what would happen in the scenario. Okay, so really for this, a lot of the test is going to be analyze the data and then apply the biology to it. So like what you learned from this year, like why did this happen now? All right, okay. We're going to keep doing these questions, so try to make sure that you keep up with the catalyst and read the comments. If I write comments for you, please read them. Okay, all right, see ya.